All right, guys, today we have graphs of cosecant and secant functions. And so what I have here is just a snapshot from the book. Did you know that these blue U-shaped things here are actually the graph of a cosecant function? And same thing here, these branches down here, there's half of one there, half of one there. This is the secant graph. And what I want you to be recognizing is that this looks really familiar. And this also should look really familiar. And using what you know about the inverse of cosecant and the inverse of secant, remember the inverse functions, those are just sine and cosine. So remember, cosecant goes with sine and secant goes with cosine. So I do want you to understand a little bit about these dotted lines here. Do you remember from Algebra 2 what these vertical dotted lines are called? They are called asymptotes, and those are present in this section as well. So I want you to know where these asymptotes come from. So I want you to think back to unit circle stuff. Remember that unit circle, the cosecant of 0, so cosecant is r over y. So what's the r value at 0? It's 1. And what's the y value at 0? It's 0. Oh, so it's undefined. So what I want you to look at here is for 0 degrees, there's an asymptote there. Notice how these U-shaped branches approach the asymptote but don't touch it. So same thing, let's do pi. So the r at pi is 1, but the y value at pi is also 0. So again, at pi, we have another asymptote here. Same thing for 2 pi. It's also undefined. This is just unit circle stuff playing in on this chapter as well. So let's go over to the cosine one for secant. So the secant of pi over 2. So remember that secant is r over x. And so at pi over 2, the r is 1, but the x value at pi over 2, aka 90 degrees, remember that? The x value is 0. So that's undefined. So again, at pi over 2, we have an asymptote here for the secant function. Okay, and then same thing for 3 pi over 2, that one is also undefined. So there's another asymptote there. Okay, so keep those things in mind, and then what I want to do is give you a chance to copy down some notes about how to graph these things. Then we're going to do 2 examples, and then we will practice it in class. So again, you guys, I can't stress it enough for this chapter that practice makes perfect. You have to practice so much, otherwise it's just going to take you way too long to do these problems. So go ahead and copy down these notes up here. I'm going to go ahead and blast right into example number 1. And I'll refer up to these so that you can kind of see what I'm talking about up there. So first of all, secant goes with cosine. And so I'm going to pretend like I'm going to graph the cosine graph for this. Remember that this 2 is the amplitude. That's the humpiness. I'm going to graph this exactly like it's cosine because cosine goes with secant. And then when I actually sketch the graph, that's where the difference is going to come into play. So remember this 1/2, this is the b value, and so that affects the period. The period is always 2 pi over b, which in this case is going to be 2 pi over 1/2, which is 4 pi. That's the period. That means from beginning to end, the distance between the 5 dots is 4 pi. And then remember to find the scale, or each tick mark. You take the 4 pi, which is the whole period, and divide it by 4, which means each tick mark is just worth pi. And notice how there's no phase shift here. There's no plus or minus shifting left or right or up or down, so this is more of a basic example. But I'm going to go ahead and draw or label my x-axis here. So here's my first tick mark, second one, third one, fourth one, starting at 0. So 0 is going to be my first tick mark because I haven't shifted left or right at all. But each tick mark is worth pi. That means that this is 2 pi, this is 3 pi, and this is 4 pi. And again, remember, you can do the period check. Is the distance from the last tick mark to the first tick mark equal to the period? It is. 4 pi minus 0 is 4 pi. So now how do we figure out what the y values are? I'm getting the feeling that most of us are more comfortable with the zeros and ones method. So for secant, that goes with cosine. And so remember, my y values for cosine are 1, 0, -1, 0, and 1. but the amplitude in this problem is 2, so I'm multiplying all these values by 2, and there is no vertical shift, so I'm not adding anything out here, so you don't even need to have that plus 0, but that's where the vertical shift comes into play. So I'm going to double all of these y values. That gives me 2, 0, -2, 0, and 2. And so far, nothing has changed about this problem versus how we used to graph the regular cosine function. So I'm going to put my dots there. At 0, my first dot is at 2. My next dot's at 0, then -2, and follow the pattern. Here's a dot, here's a dot, here's a dot, and my last one. So far, absolutely nothing has changed between graphing cosine and this one is now secant, which is weird. So if this was a cosine graph, I would connect my dots like so. In this case, this is a secant graph, so here I have the asymptotes that come into play. So at the zeros is what I made a note about. So my second and my fourth dot, I said put asymptotes at the zeros. That's what this step is. So I graphed the 5 dots. In this case, it was a secant graph, so I did the cosine 5 dots. And that's what is here. And now the second thing is to put asymptotes at the zeros. So my zeros for cosine are the second and fourth dots. So what I'm going to do is draw dotted lines there for my asymptotes. The other one goes here. Okay, next thing, the third thing says to sketch U-shaped branches in between the asymptotes. So here is where, instead of drawing the normal cosine graph, what I'm going to do is sketch these U-shaped branches, which look like parabolas, where the dots are. This one goes this way, this one goes this way. And this represents one period, you guys. If I were to continue this, because you guys know that this continues forever, but the distance between 0 and 4 pi is just one period, aka the 5 dots are accounted for. But just know that this branch continues, and this one continues, and then I have my asymptotes continue, so you don't need to draw those branches in. All I need is this middle parabola and then the left half of this one, or right half of this one and left half of this one. So use the 5 dots. Okay, exactly the same as cosine, except instead of connecting them like so, you do the parabolas. So think about how this is going to affect our domain and our range. The domain is not all reals this time because it goes left, but then it stops. Goes here, goes there, but then it stops. So we're kind of skipping all of these odd increments of pi, which is weird. And we'll get to that a little bit later. But what about the range? Does it go up and down forever? Well, this branch goes down forever, and this one goes up forever, but do you see how we have a giant gap here where there's no graphing? So the range would be -infinity to this value, and then this value to +infinity. So just think about that, and that's kind of an advanced step that we're going to be taking in class. Okay, so I want to do just the second one, and then we'll be finished. Cosecant goes with sine. And what I have is an amplitude of 3/2, so it's humpy by a factor of 3/2. And this minus pi/2 is a phase shift, and it means right pi/2. And there's no vertical shift, and the period, luckily, is just a 1 right here. No, not the period. The b is just a 1, which means the period, which is 2 pi/b, is just regular 2 pi. Okay, so what I'm going to do is I always start with my phase shift. That's my very first tick mark, so right pi/2. And then I need 4 others. 1, 2, 3, 4. And remember, my period for this is 2 pi over b, but b is just 1, so it's 2 pi. And when I divide this by 4 to get each tick mark, that means each tick mark is pi/2. Another way to refer to that is the scale. So basically I'm starting at pi/2 because I always start if there is a phase shift. That's always my first tick mark. And I'm going to add pi/2 each time to get my other 4 tick marks. So pi/2 plus pi/2 is just pi. This is 3 pi/2, this is 2 pi, and this is 5 pi/2. Okay, period check. The period is just regular 2 pi because the b value here is 1. So is the distance between my last tick mark and my first tick mark equal to 2 pi? 5 pi/2 minus 1 pi/2 is 4 pi/2, which is 2 pi. So I got my x-axis labeled appropriately. Now the last thing I'm going to do is I got to figure out where my y values are. So for cosecant, I guess I'll go over here. That goes with sine, and those values are 0, 1, 0, -1, 0. There is no vertical shift, so I'm not adding any numbers out here. So I can skip that +0, but the amplitude is 3/2. So I do have to multiply all these values by 3/2. That gives me 0, 3/2, 0, -3/2, and 0. So I'm basically going up to a 1.5. So I'll label 1 and 2. So I'm going to put my 5 dots on there. Remember, your first dot starts at the phase shift, which is pi/2. So don't put it on the x-axis, or the y-axis, I mean. Start it at pi/2 because there was a phase shift. And I'm putting a 0 there. So I have a dot for 0. Then I'm going up to 3/2, which is 1.5. Back to 0. -1.5. Back to 0. Okay, so this is what the sine curve would look like, and if I was graphing sine, I would just connect them like this. That's what our quiz was just over. Since this is cosecant, it's the inverse of sine. And so remember, what I have to do is put the asymptotes where the zeros are. The zeros in this case are at 1, 3, and 5. So my first dot gets an asymptote, my third dot gets an asymptote, and my fifth dot gets an asymptote. This is the difference between cosecant and secant. Okay, the dots or the zeros were in a different place up here. Anyways, now I just have to sketch my U-shaped branches. Okay, so this one goes up like so. This one goes down like so. It approaches the asymptotes. And remember, there should be a big gap here in the middle. And that's going to affect our range. Okay? So very, very, very similar to graphing sine and cosine, which is what we've done like a bunch of practice problems for. In this case, we are just doing the inverse of those, which makes them look like the U-shapes, okay? That is all I have for you today. We're going to practice it in class tomorrow, and then the last thing we're going to do is tangent and cotangent. And those look totally different. That's a completely separate section, so we'll get to that later. Right now, just focus on secant and cosecant, okay? Thanks for watching. Have a good night, you guys.